So, hi everyone. This is my project presentation on the topic of named entity recognition, and the paper at which I have chosen for this is end-to-end sequence labeling via bidirectional LSTM-CNNs-CRF, and the authors and the URL to the original paper and the corresponding GitHub implementation are listed. And the task addressed in this paper is basically sequence labeling tasks such as NER, post tagging, chunking, etc. Using the architecture which is comprising of a bi-LSTM, CNN, and CRF that internally uses both the word and character level embeddings. So the uniqueness of this paper is that it does not require any feature engineering or data pre-processing, and hence can be used for a wide range of sequence labeling tasks. The input which is needed for this is a corpus of 10 sentences, which is tokenized in this format, which is highlighted over here. And then it needs the glove embeddings for the training. And the output is the NER tag predicted for each token in the sentence, as like any other NER task. The approach for this is that it uses a convolutional neural network to encode the character level information of a word into its character level representation. So this is again combined and fed into a bidirectional LSTM to model the context information of every word. So every context sensitive information is present into this combined representation of both the word and the character embedding. And on top of this bidirectional LSTM, a sequential CRF layer is used to jointly decode the labels for the entire sentence. So CRF is used because you want to keep the context of the previous labels as well, in addition to the previous words in the sentence. So coming to the evaluation datasets which were used, we have used the CONRL 2003 onto nodes 5.0 and the ChemNer for dataset for evaluation. And as you can see, this is the numbers which are obtained in the original paper, and these are the numbers which I have obtained after running for 10 epochs on the first two datasets and 2 epochs on the second one, because each epoch took quite some time to run. And the numbers would converge if they were to run for a few more epochs, because the original paper recommended 200 epochs. So I'm going by extrapolation, it would come up to the metrics reported in the original paper. So let's quickly hop on to the IPython notebook. So let me take you to the IPython notebook. Yeah, so this is my Jupyter notebook. And as you can see here, this is the neural sequence labeler is the class which has been implemented. I'm sorry, just give me a moment. Yeah, so once we do the necessary imports, and this is for the error logging, and what we do is instantiate the parse config, called the parse config method, which basically initializes all the TensorFlow flags and the number of epochs and other variables which are needed, and we specify the paths for the training and validation dataset as well as testing. And then what we do is go ahead and read the dataset, which is onto nodes in this case, and you can print the dataset and you can see in what format the training requires the data to be in. This is a 12 tuple format which was decided by our group, and the index number 4 indicates what the label is, and the first index indicates the word itself. So the mention, and then the mention type, which is the NER tag which we're interested in. And then what we do is we load the model if it's already pre-saved. And once that is done, we call the read dataset helper, which is basically some pre-processing on it. And then we train the dataset, and each epoch takes some time and it trains. Here, as we can see that I've done it for like 2 epochs for the purpose of demonstration, and then the precision, accuracy, recall and F1 measures are reported here. And once that is done, we can see that I've printed out a sample prediction here about how it's going to be printed. The first 2 parameters are none for me because I'm not using the start index and the span of it anywhere, but mostly interested in the last 2 parameters. And then finally, once the predictions are obtained, we then call the evaluate method to give us the final results of precision, recall, and F1 score on the test dataset which is obtained. This can be repeated in all the 3 benchmarks and you'll obtain similar results. So, yep.